Hello everyone. Today, I would like to introduce a network anomaly visualization tool, which is designed for network administrators to analyze anomalies within a network. There are four general views in this tool. They are link anomaly, terminal coordinate, tree map, and Gantt chart. In the following, I will introduce these four views respectively to let you guys have a better understanding about our tool. To begin with, let us have a look at the link anomaly graph. In link anomaly graph, we treat every machine as a node, and a directed line between nodes indicates two machines are connected in the selected period. In this view, we can select any node as the central node, and we can also set how many hops to show in the graph. In our view, there are three different connection line colors. Green line is used to connect two normal machines. Red line shows connections that should not appear in the graph, but actually they do, and blue one indicates two machines should connect, but in fact they don't. The latter two kinds of connections are anomalous connections that we should pay attention to in this view. Next, let us have a look at the terminal coordinate. In terminal coordinate, we treat every connection as an individual, and each connection's essential attributes are shown in the view. In this data set, we may pay more attention to the recount attribute, as it indicates how many times one connection appears in the selected period. In above coordinate, we can brush any connections that we are interested in by clicking the X label. As recount value is a much more important attribute, while analyzing these connections, we may only want to focus on connections whose recount value is above certain value. For example, we only want to look at the connections whose recount value is about 30,000. We can click the label, and only the connections whose recount values are above 30,000 will display. And we can stop the brush by clicking the label again. This function in terminal coordinate helps us find some anomalous connections in the network efficiently. After choosing which property and which interesting machines that we want to analyze, we can check this selected machine is property status value by using tree map view. In tree map view, we use rectangle to represent each machine in the network, and use rectangle signs to stand for machine is status value. The larger the rectangle signs, the more impossible that there is something wrong with this machine. In this selected period, this machine's rectangle size is much larger comparing to other machines. So, we can conclude that the anomalies appear in the network may have some relationship with this machine. Finally, I would like to show you the Gantt chart view. Just as tree map, we have to choose which property and which machines to display in the Gantt chart by the tool's left panel. In Gantt chart view, time value is shown in x-axis, and in y-axis which machine are under analysis are displayed. Different color is used to represent the selected machine as property status. In our case, green represents that the machine is property status is good, and yellow means warning, red means problem, and blue means that their machine didn't send any status information to the server in that period. So, in this view, we will mainly focus on the machines whose status value is yellow, red, or blue. Now, I would like to give an example of how to use network anomaly visualization tool to find anomalies in a network. On April 3 to 5, Administrator Adam received reports from staff that one of the cooperative websites becomes unresponsive. Adam moves the button typebar to the reported period. Firstly, he refers to the Gantt chart. In this view, Adam finds web server 3, whose IP address is this one. Its status value is red, and all other machines are green. This makes Adam realize that Web 3 is the unresponsive server. He also refers to tree map view. In this view, Adam finds that Web3 is rectangular size is much larger comparing to other machines. From tree map and Gantt chart, Adam concludes that there must be something wrong with Web3. Then, Adam goes to terminal coordinates. In this view, Adam finds that Web3 connects pretty often with some outside machines such as this one. This informs Adam that Web3 maybe is under denial of service attack. To confirm his assumption, Adam refers to link anomaly view. In this view, Adam set Web3 as the central node, and he finds that some outside machines which should not connect with Web3 server are connected with it, and some inside machines should connect to Web3, but in fact they don't. This further proves that Web3 is under denial of service attack, which caused by the outside machines, such as this one. That's all. Thank you.